Welcome! In this video, we'll provide an overview of AutoCA, our CAD software solution designed to simplify technical drafting and improve productivity. Together, we'll explore the main features of the software and see how it can support your daily design and drafting activities. So, let's get started. Once the AutoCA installation is complete, activate the software by typing +AutoCA into the CAD command line. After running the command, the AutoCA menu will appear at the top of the CAD interface, as you saw that. Open the menu and select Control Panel. The first time you launch the software, a login window will appear where you'll need to enter your username, password, and activation code. After the initial activation, these credentials are stored automatically, so you won't need to enter them again. If you prefer not to see the login window in the future, simply disable the corresponding option in the General parameters under the Show Login dialog. Uncheck this box and you're good to go. Don't forget to also click on the Save Environment button. Now, the control panel can be opened using this button. This panel contains the general settings used throughout the software. First setting allows you to define the unit of measurement. It's important to select the same unit that is used in the drawing or formwork model you are working with. For example, if your drawing is created in meters, then select meter. If it is created in centimeter, like in my case, you should also select centimeter here, and so on. Maintaining consistency ensures that all reinforcement elements are generated correctly. Next, we find the font settings grid. These predefined styles cannot be deleted, although additional styles can be created if needed. For that, you just need to click on this plus button that says adding a new style. The default styles, though, will always remain available. The selected styles are automatically assigned to the various objects created within the software. By modifying a style, all related objects immediately adopt the new graphical standard, including the text appearance, graphics, colors, and other visual properties. This allows you to quickly adapt the entire drawing environment to your company's standards. The final grid allows you to define the colors used within the drawing. These colors should be configured according to the CTB file used for printing. AutoCA works with 5 predefined line weights, ranging from the thinnest to the thickest pen weight. Each category can be associated with one or more AutoCAD colors. Colors can either be entered manually by typing the color number separated by commas, or selected from the standard color picker. For example, if black is assigned to the thinnest pen weight, all colors listed in that category will print as black, but with the corresponding line thickness defined in the CTB file. One important rule is that the same color cannot be assigned to more than one line weight category. If a color needs to be moved to another category, it must be first removed from its current location. Otherwise, the dialog will not allow the configuration to be saved, since a CTB file can associate a color with only one line weight. Also, when entering values in your field, simply typing the number is not enough. You must confirm the value by pressing the Tab key or clicking into another field. Otherwise, the change will not be registered. This behavior is consistent throughout the software and applies to all AutoCA dialogues. And now we arrive at one of the most important sections of this panel. At the bottom of the window, we find the controls used to manage working environments. A working environment contains much more than the settings displayed in this dialog. It stores the configuration of all AutoCA dialogues and tools, whether you are creating meshes, bar series, reinforcement bars, or other objects. Each tool contains a customization setting that define appearance, colors, layers, and in some cases, calculation parameters. All these settings are stored together within a working environment profile. By default, this profile is named AutoCA. We strongly recommend that every user creates a personalized working environment. If modifications are made while using the default AutoCA profile, future software updates may override the file and reset all custom settings. For this reason, it is good practice to immediately create a profile with your own name, your company name, or a project-specific name. Working environment files can also be shared across a network. This allows to work with exactly the same standards and settings, ensuring consistency across an entire project team. The Save Environment as Default button stores the current environment in the local computer registry. This ensures that every time the software is launched, the same settings are loaded automatically. If the environment is not saved as default, any changes made during the session will be lost when both AutoCA and the CAD application are closed. The environment can also be saved to an external file. For example, we can save a profile named test to the desktop. Later, we can reload that file whenever needed and immediately know which configuration is currently active. This provides a simple and reliable way to manage different standards, projects, or client-specific configurations. Now we're going to look at one of the most common reinforcement workflows in AutoCA: creating, modifying, copying and managing distributed reinforcement bars, and finally generating the corresponding bar schedules and tables. Let's start with something very simple. First, I'll create a basic reinforcement bar and place it onto the drawing. For that, you will need to specify the length, which initially is 300 centimeters. And also you will have to fill all the other yellow tinted text boxes, because the software won't allow you to create anything unless all the yellow brackets are filled. So number of bars is gonna be 1 for now, and diameter are gonna be 12. That's in millimeters. Right now, the Create Bar button is live, and I can click on it, and also I can place that bar I just created. One single bar with 12 millimeters in diameter and 300 centimeters in length. Once it's created, I'll make a few copies of it. For copying AutoCA elements, you will need to use the copy elements proprietary command. Keep in mind, this is not the same as the standard CAD copy, so it's proprietary. Notice how the bar numbering continues automatically. Every new bar receives the next available mark number without any manual intervention. 1, 2, 3, 4, 5. Okay, before moving on, let's also generate a quick bar table using the all bars in drawing options so we can see how the software is already tracking our reinforcement information. As you can see, here we have all 5 bars. Now, let's switch to a clean formwork drawing and start a more realistic example. We'll create a simple distributed reinforcement bar arrangement from scratch. And now, as we go through the definition process, I'll explain every option available in the dialog. So, as we talked about it earlier, we need to fill all the yellow text boxes to be able to create anything. So, I will enter as a number of bars a 1 and for diameter a 10. But right now I want to distribute these bars along these slabs, so we will need to also insert a distance between every bar and an extended distance, which will be the full distribution distance. For that, I will use this button, which is the graphic extension. I will define this length, which is 5 meters, and this is exactly what's entered here in the text box. And together with the 15 centimeter distribution distance, it's all already calculated that we have 34 bars. Okay, let's put this bar onto the drawing. I want only the outside bar, and let's put it over here. One thing worth mentioning is that in practice, most users rarely create complete bar definitions from scratch. Once you understand the logic, you might only perform a full definition a handful of times. After that, most reinforcement is created simply by copying and adapting existing bars. So we need the graphic extension showed, and right now we have the little blue arrow representing the distribution distance, the full distance. Now there are some other features that you might need to know of. Let's go into the bar properties, modify bar, and at the distance between the bars, we have another checkbox. And if you hover over here, your mouse, it shows extremes require. These extremes mean that if you check this box, then you will have another bar in plus, because the distribution will start and end with 1 bar. And if you uncheck this, the last bar will disappear in theory, because we are not forcing the distribution to have a bar on both ends. So if you want to force it, you can, and you will have a bar in plus. But if you don't need that, you just uncheck this box. And after that, we have several other checkboxes down under the visualization menu, and let's walk through them. The real view means that you will have the exact thickness as it is mentioned in the text here. So what you define in the diameter, that exact thickness you will get if you check this real view. If not, you will only get a simple line. The frame is the frame around the mark number. You can enable and disable that. The position is the full mark hidden or shown. The show diameter is the diameter parameter in the label of the bar. Sides dimension, this is the smaller number indicating all the sides. Bending angle we also have that one. If we had another side, we could see that. Let me fix that. As you can see, now I have multiple sides, and also we can have a bending angle. Here is the bending angle. So you can show or hide it. Show angles 45. It means if you want to see even the 90 and the 45 degrees or not. Right now we don't see them. So there's an option to see every single angle if you want, and there's also the option to only see the odd numbers in the angles. The graphic extension is this arrow indicating the full length where this single bar is distributed. We have the distance, which is the distribution distance between individual bars. The number of groups, that's toggleable also. And for that, you need to specify a group number. And as you can see, the label starts now with the multiplication with the group number. So we have that also. We have distance, we have number of bars and the different types of them. We can have also the count of total bars, and also length, which is easy to understand. Radius, if we had circular bars, a type. This is where you can enter the type. You can create a new category like B500C. That's what we use in Europe. Add that, and we have the type, and that is toggleable also. Still type is the main type. The simple type category may be a subcategory if you want to add that. And lastly, we have notes if you want to add something like a mention, and now we can write that. So these are the different options inside the bar modification panel. Keep in mind that none of these settings are permanent, so anytime you feel so, you can go back to the modification panel and change all these settings we just went through. You can do this either by selecting the bar and accessing the right-click context menu and click on Modify Bar, or we have a dedicated button for that, which has a pencil on its icon. You can click on it and select your bar, or bars even, which you want to edit. Okay, after placing the first distribution, the hatch and the boundary should automatically appear. If the display is not exactly what you want, don't worry. This is something that can be configured once in the Customize tab. Just make sure that you're in the bars menu. Click on the Customize and search for Graphic Application field. And under that, you can find a boundary and the hatch checkbox, which you can disable. Apply the properties either to all the bars inside this drawing, or just selecting one. Right now I'm gonna select my bar, press space, and now the application field, so the boundary and the hatch, are both disabled. After that, you typically won't need to adjust it again, but you have the decision to have these graphical aids or not. Also, you can change the boundary color, and the same is true for the hatch itself. Okay, let's go back to general. And now let's talk about editing. Suppose the shape we created is not exactly what we wanted. That's perfectly fine, because any reinforcement bar can be modified at any time. We can edit its geometry, remove hooks, remove side, add new hooks, completely change the shape, or make other adjustments. For demonstration purposes, I'll add a new side to this bar. Let's say I want another side that's 40 centimeter long. I press space and here we have our new side. But for the sake of this example, I will exaggerate it a little bit so you understand that you can do anything you want with this bar. 25, 120, it doesn't matter because you can do any shape with AutoCA. Okay, so yeah, we know that it's a little bit exaggerated. We don't use anything like that in the real world, but there's the possibility to make interesting things. So I hope with this example you can you get the point that it's very easy to use. Now let's remove unwanted sides like these ones. Okay, I use the remove side button for that. The hook does almost the same, only with 2 sides, so you get a complete 180 turn with the hook, and I can delete the hook. What is important to understand is that this reinforcement object is actually a package of linked elements. If we modify the bar itself, like stretching it, the arrows, labels, quantities, lengths, and other associated information update automatically. Like if I change the length of this arrow, you can keep your eyes on the number here. We immediately get less bars because the distribution distance got a lot smaller. So this is the whole package. Likewise, if we modify the annotation components, the reinforcement data remains synchronized. Like if I want 12 millimeters in diameter, I can do that just by editing this text. Click away, and now we have a 12 diameter bar. You can even check that with a quick bar list. Right here we have 12 in the diameter section. If I want bigger, I just edit this text. I say 16, click away, space, and now everything, the diameter, the weight, and everything gets updated. By the way, let me put this in English, and now you see, you can understand the list better. Let's assume that we need another similar reinforcement bar elsewhere. Instead of creating a completely new definition, we simply copy the existing one. This is usually the fastest and the most efficient way doing that. So let's use the AutoCA's copy. That's very important that you do not, under any circumstance, use the standard AutoCAD or CAD copy, because if you do that, you just copy simple elements like hatches and lines. But this is not an AutoCA entity anymore. So keep in mind that you always use copy elements here in the AutoCA control panel to make multiple AutoCA elements. See? Now they are AutoCA components because they got a new number. The first one was 6, this is 7, this is 8. So it's all updated. So as I said, the AutoCA copy and mirror functions, also the mirror, work somewhat differently from the standard CAD commands. However, the move and rotate behave exactly the same as you would expect from traditional CAD tools. So that's just a simple move command, and I can move these bars around. And likewise with the rotate button. The only thing that with rotate, you might need to update it by moving the bar or by modifying it, because sometimes the graphic gets messy but after an update, as you saw earlier, everything goes back to its place. Let's tidy up a little bit here. Let me show you the mirror command. So this is another proprietary command for the AutoCA because it's also copy, but with a mirror integrated into it. So if I select this line as the mirror plane, I can choose whether to delete the source element or not. So if I say don't delete it, which is the default, then I immediately make a copy of the source bar. And that's why you need to use also for the mirror command this proprietary mirror elements command from the AutoCA control panel. Okay, a quick side note. If you need to copy reinforcement from one drawing to another, AutoCA provides a dedicated copy and paste commands specifically designed for reinforcement objects. So it's somewhat similar to the in-drawing copy command, but it's in between drawings. So you have to use the copy auto_ca command for that if you want to transfer like these elements. First you select them, press space or enter, and select a reference point, basically a grabbing point from where you grab these elements. And going to the other drawing, we have the paste AutoCA command, and now we have a marker, a box with the grabbing point we specified, and we can paste our bars in the new drawing. BricsCAD asks if we want to keep the current values for pasted positions. If you say yes, you will get the same mark numbers as from the source drawing, or if you say no, a new numbering will start with 1. As you can see, 1 and 2, but what we copied were 6 and 7. So that's how you transfer bars from drawing to drawing. Now I'll create several additional reinforcement positions. The easiest method is usually to use reference points from the formwork drawing. So as I see, I have a 2 centimeter cover here for the reinforcement, and I select the formwork as reference point. So when I paste my new bar on its new place, the exact same cover distance will be kept. And this is the easiest method for copying bars. Let's stretch it into place. And a quick side note for the stretch command: if you are not familiar with this very useful command, you can just type S in the command line, which brings up the stretch command, press space, and now you will be able to specify a rectangle in which you can include all the vertices or vertices of a polygon or polyline that you want to move elsewhere. So if I want to shorten this bar, I just need to include into the marker this end. So when I select it and press space, I can grab a reference point and I can bring the two ends closer to each other. So keep in mind that you don't stretch like this, because you can do nothing when you did not select any vertices. So these are the points you need to grab with the lasso and bring anywhere else. So that was just a few words of the stretch command. You need to get familiarized with this one because you will use it a lot when you work with AutoCA. Okay, let's make some more reinforcements. I'll intentionally keep at least 2 reinforcement positions identical in size. That's 696, 696. The total length is the same, and also the diameter and everything else. And as for the others, I already showed you how to stretch them and how to change its parameters. For the example, I'm gonna do the same again. Let's make these sides a little bit smaller, like 22. Now it's 18. And also you can edit all the sides text box so it gets stretched for the dimension I wanted. I will do the same here also, and let's edit both bars through the modify bar panel. You will get an element filter where you can indicate what you want to modify. Now we have a purple indicator where indicating the area where these two bars are distributed. Let's change their diameter back to 10, and now they both get updated with the correct parameter. Let's change this side too. I want to move this one. Okay. As you can see, everything I do with them automatically gets refreshed. So here's where you can save a lot of time when you don't have to go through every single bar to update its information. You just stretch them, move them, edit them, and everything updates automatically. Now that we understand the basic rules of bar modification, let's convert this drawing into a real meaningful slab reinforcement drawing. For that, we will need to use these elements, which are the upper bars, and we will also use simple bars with no additional sides. So I'm gonna copy with the copy element command, and I'm gonna delete these two sides. So we have the lower bar and the upper bar in this position. Let's not forget to place these arrows correctly. You can also leave a note on the bars, as we saw earlier. Here in the notes bracket, you can write that this is the lower one. You just need to hit enter, and now we know that this is the lower reinforcement bar, or the inferior one, and this one will be the upper bar, or the superior one. Okay, so we have this direction. We can do the same to this one. Copy elements. Copy elements. I just have the shortcut COP to make my life easier. Okay, delete side. That side's already deleted. Place the arrow, and all the information are already updated. Let's add the side to here, and let's stretch it all the way to here with a cover. Obviously, we can delete these bars sides, so we have a continuous distribution on the lower side, and we will do the same to this one, so these two stay the same. And the last thing, this position, let's edit these sides. Let's copy this one, and let's delete its sides. Okay, so now one last thing remains, and that's to copy this one and place it over here with this shape, because this long upper bar is distributed only to this point, and we need something on the upper side on this area as well. So that's how we resolve this problem. Okay, that's that. So we have everything arranged. So now what we did was we copied a lot of bars and changed their shapes, but we left two bars being identical because it will be important later. Now let's look at mass modification. I suppose we decide that all these bars should have a different spacing or a different diameter. Instead of editing them one by one, we can update all similar bars simultaneously, as we saw earlier with these two bars. But now we will do it in a bigger scale. So I'm gonna start the MD command, the modify command, modify CA, press space, select everything, including lines, polylines, hatches, it doesn't matter. The auto CA command knows what to select exactly, and also you will get this filter, so you can narrow your search down. Now let's say that we want to increase the diameter of our bars, so we have various written here in the diameter bracket. That's because we have 10s and 16s in our drawing. So if we want to fix that, we can just simply write 12 into the text box, click away or press tab, and now you can check that each of our bars got up to the 12 millimeter diameter. So that's how you can mass update your bars. You really don't have to meticulously go through every detail, because if you feel like you are struggling with auto CA, that's probably because you are doing something wrong. The workflow with auto CA should be seamless, without struggle. There's a possibility that you don't know of a feature. That's maybe why you're struggling. This software was created with a mindset to make life easier. It doesn't supposed to make your life harder. No. Contrary. No. Exactly opposite. If you feel your work sluggish when you work with auto CA, feel free to contact us and we will help you understand your tool better. And this is why this tutorial is made. So, parenthesis closed. Let's move on. We saw the mass modification. We can achieve the same result if we select everything and just click on the right click context menu, the modify bar, and this is the same modification panel. So you have options here. Once everything is ready, let's generate a bar schedule. You can also update this one and include the new bars into the same list, but let's try creating another one. All bars in drawing and create table. And here we have from number 1 all the way to number 15, all the bars included inside the same bar schedule. We have a total weight of a little bit more than 4 tons, and we can see all the shapes of our bars in a miniature. So what I'm gonna do next is I'll copy the entire slab and create a second one. For that, I will also use the copy elements command. I will select everything, all the lines and hatches included, because now we're not just copying the bars, but all the formwork too. So here we have another concrete slab formwork with its reinforcements. We will generate a separate bar list for the new slab and then create another one that includes the reinforcements from both slabs. Now we have twice the amount of reinforcements. Now, at this stage, let's discuss numbering. Using the renumber function, renumber CA, I can reorganize the reinforcement marks. And remember that mark number 1, where are you? That mark number 1 can only exist once within a drawing. So you won't have two different shape of bars with different parameters having the same mark number. That's impossible. If you see identical numbers, that means that those are identical bars as well. So in our example, for the second slab, I renumber the reinforcements starting from mark 100. For that, I select everything, and here we have another yellow text box. That means we are obligated to fill it. This is where I write 100, because that's the mark from where I want to renumber our bars. I press on the renumber button, and now we have 9 elements, which has the first position on the 100 mark, its last position on the 108 mark. Now we can close it, and we can check the result even on the bar list. Here we have 9 bars from 100 to 108. And if we examine the big table, we'll notice something interesting. Some reinforcement marks have different numbers, but are actually identical in diameter, shape, and length. Like, for example, the 6 and number 100. These are both 12 in diameter, 582 in length, total length 593. So these are basically identical bars, but have different mark numbers. And this is where grouping positions becomes useful. I'll run the group positions operation. Then I will need to select individual bars or just select everything, all bars. I will select all bars. I will need to decide which position number to be used for identical ones. If we check this box, the program will automatically use the lowest value. So click OK. And now let's update all the bar lists. Right click, bar schedule, and update. You can notice that this previously much bigger list got a lot smaller. That's because we have grouped elements now. So we have a number 6 here and the number 6 here also. So as I said earlier, if you see identical numbers, that must mean without exception that these two bars are identical. You can also notice that some mark numbers disappeared, like 8 or 5, and the numbering sequence is no longer continuous. And this is completely normal. We selected that the program should use the lowest value when grouping elements together. So, to restore a clean numbering sequence, we simply run renumber again, like so. Renumber CA, space, select everything, space again, and let's renumber them from starting from 100. And now we have 18 elements, but because of the grouping, we will have the maximum position number at only 105. So close that, and now we have a clear numbering sequence. This number 1 bar must come from here. As you can see, we selected to group everything together, so we can get back to the selection only and select only those bars we will want to see. It seems that you cannot change subsequently the type of the table, but you can always create another bar list only with the selected elements. So this is all bars in drawing. This is only the slabs we created. And also, if you try to renumber only these bars when they are under grouping, there's going to be an interesting thing. So let's try to renumber these from 200. Renumber. Close. Now all the bars changed up to 200 and something because they are grouped together, even though I selected only these ones for renumbering. So as you can see, from the point that you group these bars together, they behave like they are one. Okay, now we arrived to another feature that's called element assign. I'll create an element with this button, element assign. For that, I need to select some of my bars, press space, and I can see in this dialog that these bars are unassigned right now. So let's go to the Manage tab, create a category. I say slabs, okay, and create an element inside the category. And I say this is slab on the +30 level, okay. Let's create another one. Sorry, not this one. So click on the slabs, create a new element, and this is gonna be slab on the +600 level. Okay, we can close this one. And now we have our new category with these two elements. This one, the first slab, is gonna be the lower one on the +3 meter level. And you can see that some tables have already changed. And let's assign these bars to the +6 level. Okay, and this table changed as well. What's the difference? Well, the name of the list got enlisted here, so we can see clearly that these bars belong to the +6 level slab. On the list where we included everything, we can see these two slabs separated, so we no longer have unified bar numbers, but instead we have grouped by element assigned. On the summary, we have these two enlisted as well with their respective total weights. And at the bottom of the list, these two values are added together. Now this element assign feature gives us a lot more options when it comes to bar list generation. So our possibilities are as follows. We can select individual bars like these three. I can create a bar list of them. Okay, we can create a bar list from all bars in the drawing. We have that. We can create a bar schedule from the selected element type, like the first slab from the +3 level, or from the second one, or both of them. And of course, we have subcategories to give us more specific filtering by revision or by style type. So these are our options for bar schedule generation. As you can see, this gives us a lot of flexibility when organizing project documentation. And as an additional tip, remember that the entire reinforcement assembly remains dynamic. If the formwork changes, we can stretch both the formwork and the reinforcement together. Like if we need to stretch this one, right now it's a block, but let's explode it. If we need to stretch this formwork by 2 meters, 200 centimeters, now we are asked to change all the positions of the number 201. This is because this bar is grouped with this one here, but we only stretched this one. If we say no, and also no to another bar, no again, no, then we get some new bars with new mark numbers. But if we chose to stretch everything together and stay with the same numbering and change all the positions, then this stretching will not only apply to these bars, but to these as well, as you can see. I think that I don't even have to emphasize how good this thing is. If the reinforcement adjusts along with the geometry, we can save a tremendous amount of rework if something changes. I also want you to pay attention that these two bars we made purposely identical. These got the same element numbers, so they work together as one. If I stretch one, the other one stretches as well. So this is the huge benefit of grouping all the bars we want together. So this is essentially the standard workflow when working with rectangular or parallel reinforcement distributions. Finally, let's look at one more useful feature. We have these bars running continuously from one side of the slab to the other. Once the bar is created, we can use the break bars function. And there are two ways to do this. The first is to manually specify a breakpoint. Right now, I will tell the software to break my bar here on the axis line. And now we have two new bars, which I can move freely, indifferent from the other bar. The second option for breaking bars is to instruct AutoCA with the options menu to split the reinforcements into predefined lengths. For example, the cutting should now be 600. We can select a scheme how to cut the bar, and we also get simplified sketch of what kind of bars will we get out of this cutting. So if I select this scheme, I'm gonna have one piece of 600 centimeters bar and one piece of 403 centimeters and another one with the full 600 centimeters. And this result changes when you select another scheme. You can also define an overlapping distance, and we can also put automatic dimensions onto these new bars. So let's do that. Let's click on break, and now we have 3 bars exactly as described in the dialog. We have a 600, a 403, and a 600 again. So as you can see, this can be extremely useful when dealing with transportation limits, for example, or fabrication requirements, or construction constraints. And with that, we've covered the complete workflow for creating, copying, modifying, and grouping, renumbering, and scheduling distributed reinforcement bars in AutoCA. If you'd like to explore more advanced workflows, don't forget to check out our Tips and Tricks playlist, where we regularly share practical techniques and productivity shortcuts. Thanks for watching, and we'll see you in the next tutorial.